Greetings, dear friends. One of the subscribers sent a 3D display for repair. For Sony PlayStation, this is quite a rare device. I have never dealt with such before. The problem is that the monitor does not turn on. At the moment of turning on, the blue indicator lights up, then green and red, and then restarts. The image does not appear on the screen. This is the problem of the monitor for me. They have already tried to repair the power supply and found no problems. They sewed the flash memory chip, but since this did not help, they completed the repair on this. Why should we try to restore this strange device? Maybe something will work out. Let's start with the disassembly. So, the back cover from the monitor is removed, examines the condition of the electronics boards. This is the power supply and the main payment. The flash memory chip is here. Well, the power on the board is all present and even the memory is sewn. Then the only thing left is to get a magic device that will show us the faulty component. In this case, we mean a thermal imager, judging by its readings. The main dress gets very hot. One of the three processors, the one that, of course, by coincidence, the manufacturer left without a radiator, heats up to 75 degrees. In fact, in idle mode, which should not be obvious, so it was assumed that the processor is faulty and should be replaced with the owner of the equipment. It was agreed that most likely this processor failed, but the information is not accurate to find out. River needs to get the same working processor, put it on the board and look at the result, agreeing with all the risks. This processor was purchased. It is new and original, according to the seller on AliExpress. Well, let's hope he's not lying. Let's begin the replacement by first washing the residues of the flash memory flux so that during further work it does not spread over the entire board. Next, I unsolder the radiators from two other processors. In this case, I use Station C. A 45. With a soldering iron, the thermal interface between the processors and radiators dried up almost to the state of stone and had to be scraped off in places. Now about the technology of replacing the processor, since it is in the BGA case, we will need a bottom heater for the board. It is also a preheater, and in my case it is a separator for removing display modules. The table size is 14 inches, just enough for our board. I put brass posts on the board so that between the board and there was a small distance from the table. I put the board on the table and including heating, the bottom temperature is 200 degrees. This is the maximum that can be squeezed out of my separator I apply to the processor. Plus, now it's NC 559 as soon as the table reaches the set temperature. I turn on the top ceramic heater. Its power is limited to twice the nominal value so that there is no risk of overheating the payment when the chip is heated to the point of melting the balls. Push it and remove using vacuum tweezers. Next, I will prepare the board for setting the new processor, removing it from the mounting contacts. Old solder was first simply a soldering iron and then a copper whip. I flush the spent flux, after which you can move on to installing a new processor. But you should not rush the wandering rich PU. They often arrive raw. And before installation, you need to listen to them, so that when soldering, there are no problems with the surface of the Texolite substrate, with the subsequent failure of the parts to dry at a temperature of about 110 degrees for 5 hours. After the procedure, you can continue applying to the mounting contacts of the board. New Plus. I am now using a good original Flux Plus, using it exclusively for Bogaup. Therefore, the tube lasts for a long time, so I have been applying a small amount to the mounting contacts for 2 years and distributing a thin uniform layer, using a clean finger degreased in gasoline galoshes before this procedure. Next, I wrap the processor according to the key and align it according to the markings on the board, including the bottom heating, wait for 200 degrees and turn on the top heater. Once the balls under the processor have melted and the chip is in place, the process can be completed, monitoring the melting of the balls. It's just that if, with a slight wobble, the chips shift and return to their place, it means that the solder under it has melted and you can turn off the heaters after the board cools down, connecting it and checking the result. In my case, the monitor is working and displays an image on the screen. This means that the chip replacement procedure has been completed successfully. Well, it was really a malfunction of one of the processors. During assembly, I installed fresh thermal paste on the radiators, and also put the radiator on the new processor. What the manufacturer, Sony Corporation, did not do was fix the radiator of the 7000 sticker specifically so that someone would actually bomb me in the comments about this. I just think this installation method is the most optimal in this case. Tested the monitor for several hours after assembly. No additional problems were identified except for one unpleasant moment on the matrix. There is a vertical band width of 1 pixel. The problem of the matrix, unfortunately in this case, only its replacement will help. Otherwise there are no problems. Well, dear friends. With that, Merrymont is over and it's time to say goodbye. Thank you all for your attention and see you in other repairs until soon.